Okay, so you might have seen that this middle part disappeared from the last section. So we no longer want to set a pixel to red, but we want to do something more interesting, a bit more image analysis. So probably the first thing that might be of interest is let's get the average color of this image. So we want to know. We know roughly it's probably something around gray, but let's find exactly what the average RGB value of this image is.
Yeah, sure. So how we would do that? We would have to look at every single.
Yeah, so whenever you
Pixel.
want to average, you essentially go through all the items you are looking at, you would sum them up, and divide by the total number of items you have.
All right, and we're going to sum up red, green, and blue sort of individually.
Right, right. So it's a separate average for R, G, and B.
So we'll initialize a few variables, I guess. And then we'll run, so to loop through the image, I guess we'll use a double for loop with.
Yeah.
So
now, as Jack is writing that, the thing is you could use a single for loop because it's a 1D array that we're using in this case, but just for our own sanity and our own understanding of the image, it's better to use an X and Y for loop so we can understand how the loop is accessing the pixels.
Yeah, so we're going to loop through the height and the width, which allows us to go sort of basically scanline down the image. So we're going to do that sort of index calculation again, which is y times width plus x, and then we'll get the pixel. And all we're going to do is add on the totals. And after this all runs, this won't work because we have to cast these because they're 8-bit integers, and in Swift, it doesn't like it when you add different types. It's worrying about overflowing and stuff.
Okay.
All right, so there it goes, adding up the colors, but we haven't really divided them yet. So let's do that.
And now, one thing about that is, if you noticed in Playground, dealing with images is actually very slow. Hence why we actually use a very small image. But when you run the application, when you build your own app, it's much faster. But just in this Playground, we suggest using a small image so it doesn't take a very long time.
Yes, in Playground, as you saw, as it's running the for loop, every loop it's going to try to display something to the screen. So even though these operations are incredibly fast, after it does this, it takes a little while to show you that it's done something. And so what ends up happening is everything is really slow. And it tries to run all the time. So we're going to have to type without stopping. And here we should be able to get. All right, so this time we'll let it run. It's going to loop many times. And again, in a compiled code, if we were able to compile this code, this would run really, really fast on it. But here we have
this goes to 13,400. Yeah. So, okay, so we have the average color. The red average is 107. So you can see that here. The green is 109, and the blue is 110. So roughly gray, because these are similar. So that corresponds to essentially a kind of a mid-gray color, which if you really zoom out of this image, it is a mid-gray.
It is a pretty gray. We're not having the best day here in Toronto.
Okay, so this is good. Now, next thing we can do, now that we know the average color, let's just make sure that this is roughly the average color. Let's take every color that's lower than the average, let's just set it to black.
So since we don't want to run this again, let's save these values out so we don't have to recalculate it. All right, we're gonna.
So
this is 107. So instead of making it run all the time, since we know it's not going to change, 109 and 110, and we can delete all this everything up here, which is going to cause Xcode to complain. And hopefully it will spare us from
a crash.
Right. It's looking less likely as it goes by. Yes.
Now, just one note is that this is a beta version of Xcode that we're using at the time of taping this lecture. the latest Xcode wasn't available. So,
Okay,
and
it just died. And now we're back.
okay,
Okay.
cool. So, all right, so we have the average colors. Now we want to go through all the pixels in the image, and anything that's lower than the average, so lower than the average red, average green, and average blue, in those cases, we will set it to be black.
Yep, that sounds good. And now I'm wishing that I did not delete the whole thing because I have to write these for loops again. Y times the height, the width, plus x. All right. So the fun part is when you get the pixel. So what do you mean by less than the average pixels?
Right. We have to define exactly what we mean by that. So what we mean is that if the red and the green and the blue is less,
So they're all less than these
they're
values.
all less.
I see. Like,
Maybe a better thing is to say the sum has to be less than the sum of the average. So
Yeah.
in that case, we're almost dealing with grayscale images.
pretty much. I think that makes a bit more sense, or else maybe less of the pixels will be below average because it would have to satisfy all three, right?
Yeah.
Yeah. So we'll do that. So if you know what, let's add them up here. Let's sum average red, green, average blue, and then we're going to also add up the pixels of the pixel. And if that's less than the sum, we're going to set it all to 0.
Yeah.
And then we will set it back into the image. And once it stops complaining, right, because these are
So we have to typecast them.
yes, we should typecast each of them because they're really small and it might overflow if we don't. All right, so this is happening. This shows you how many times the inner for loop, the if statement is being getting. It's roughly half.
Should be about half.
Yeah. Ooh, that's an interesting effect.
Yeah, so if you can see in this image, it looks roughly the same, but all the pixels that are darker than the average are now set to black. Something else that we can do that actually would be useful is we want to increase the contrast of the image.
Mm-hmm.
But so maybe what we can do is we'll increase the contrast, but we'll increase the contrast separately for pixels that are brighter than the average and pixels that are darker than the average.
Interesting.
So,
yeah.
But let's do it for both first. So essentially, once we get the pixels, if the pixel is above the average by a certain amount, we'll multiply that by a certain amplifier.
Mm-hmm.
So essentially, what we mean is you can actually erase this sum check.
Oh, only the if? Or
Only the if.
Sounds good. Let's comment it for now, in case we need it later, because we're going to do something different with average, right? Okay.
Right. And so what we want to do, essentially, for each of the red, green, and blue channels, we want to check if it's how much it's above the mean, and whatever it's above or below the mean, we want to multiply that by 2.
I see. So it increase its difference from the mean, like sort of push it farther a bit.
Push it further from the mean, exactly.
So what if it's less than? Do we not?
So for now, let's keep that in. So even if it's less than, we push it away from the mean. And then later on, we'll come and we'll actually change.
I see. That makes sense to me. When dealing with these pixels, though, you have to be a bit worried about overflowing them, going up. And Swift is really strict on overflowing. It'll actually crash at any point if you overflow any sort of integer or value. It'll just give up. So how? Yeah, there's a. So how we would do this? We would want to sort of get the red delta. And are we comparing it to the average pixel, or I guess the
No,
average
each of the
channel?
channels themselves. So we can say red delta is pixel.red minus average red. We
Mhm.
probably have to typecast pixel.red.
Yes. You're getting the hang of this. Nice.
And same thing for the green and blue.
Yes, let's just do some copying here.
So now these deltas are essentially how far away we are, up or down, from the average. And we want to be twice as much away from this, from the average. So
Yes, so we're actually just gonna, we're just gonna set them back and do some math. So we basically want to add double the difference, plus 2 times the delta back onto the pixel.
right, except you should start with the average, right? Because
I see.
when
Yes.
we get these deltas, we know how far away we are, and when we set it back, we should start from the average and then decide how far from this average we want to be.
That makes perfect sense. And we're going to have to do some checking here. Okay, and here's where we have to do some sort of, first we're going to have to cast it. We actually have to cast it down to a inside 8-bit integer. And it's likely going to crash due to overflowing, but we shall be able to fix that.
Question: if we had to cast it when we declared the let, for example, the let deltas, what does it have to be cast again?
Yeah, here we casted it to an integer, and here it's back to a, this here it's a 32-bit, and here it's back to a, sorry, maybe they're not inside, to an 8-bit integer. And maybe we don't have to do that. Oh, it is a 8-bit integer. Now it's complaining about something slightly weird. Oh, it's because average, right. Because this is also a 32 integer. So let's cast, we cast the whole thing instead.
Okay.
And this is where it might crash on us. And it probably already did. So how do we deal with the problem where if it might go out of bounds? Because as we said, pixels are 8 bits, which means they can only be from, each color channel is from 0 to 55. So an interesting way.
Yeah, so let's check if it's below 0 or above 255 and essentially cap it at those limits.
Right. Yeah, so I guess a sort of trick is we can use min and max to do this for us. So we want to make sure it's less than, it's less than 255, so we always take the minimum of it and 255, but we also want to make sure it's greater than 0. So we can take the maximum of that with 0.
And so let's look at that carefully. So when you take the min of 255 and let's say 256, the smaller one would prevail, and so you would get 255. So essentially it's capping at 255. But if it's negative 10 here, that min doesn't really help you. That's where the max comes in. So in the max, if you have negative 10 there, you take the max of that and 0, so then 0 would prevail. So this essentially is providing a capping on the bottom end at 0 and on the top end at 255.
Yeah, and it's a quite effective way of doing so. And I'm missing some parentheses. So now I should run. Hopefully. Please run. It is not running for some reason. So there we go. I finished again. Yes. It might also be here because so in this case, I think maybe it's already overflowing, so this cache might be crashing. Because if our value is overflowing and then we create an unsigned integer, 8-bit integer out of it, that may be enough to cause it to crash. So maybe if we move this outside. So we basically, once we get an integer and we after we cap it, then we assign it. That actually makes more sense. Oh yeah, there we go, live debugging. Yeah, so the issue there was because this is the value that potentially overflows, and it would overflow if we cast it to an integer. And so I'm trying to find a good way to say that the stupid me casted it first before we did the checking, which completely defeated the purpose because it was already casting and already crashing before we set it back. And there we go. Here's an output.
Yeah, so if you look at this image, it looks sharper. It has a higher contrast. The colors are more vibrant. And you've just created a contrast increasing filter.
Wow, it looks
Now,
a lot better.
let's
Yeah.
push that to the extreme. Let's make that 2 into a 10. And then what we'll see is maybe too much contrast in that case.
Yeah, let's see. I mean, this image looks really good. It looks like we're having a really good day. Where in reality, it's more of a grayish, gloomy day. Alright, so it's doing its thing. And yeah, the more we do here, the slower it's going to be. But again, if this code was compiled and then ran, it really wouldn't be it would be instant.
So for compiling code and we'll get into that detail in the next course in this specialization.
Wow.
Okay, so here's an image, and you can see the contrast is it's too much contrast. You can't really make out some of the details very much.
Yeah, you've lost this whole part of the building.
Yeah, it's interesting. The contrast increase for the brighter areas perhaps doesn't look as bad as the darker areas. So if you look at this image, for example, some of the brighter areas, actually the contrast enhancement looks it's kind of a cool effect. But the darker areas are just now all black. So let's do a smart contrast increase.
Sure.
So that if the average color is bigger than the average overall image, we do essentially we do 10. But if it's darker, let's say we do 2. So the contrast increase on the lower side is less than the upper side.
Sounds good. So let's put this if about here, around here. Indent it properly. So the thing we're currently doing, we want to do it when it's brighter. So have a greater than.
But I think let's not put this in the if. Instead, we can change that 10. We can either set it to a 10 or a 2, depending on if the pixels...
Let's do that. What should we call that? That is sort of the modifier.
Sure.
And we'll set it to... I see what you mean. So we're going to move this code outside. And we're going to use modifier here instead.
Yeah.
Its execution is turning me off. It never executes it.
Every time we change the code, it's the playground.
It's reloading the image. So if it's less than some, I'll set it to 2.
Yeah.
All right, got that in.
Okay, so let's see how that goes.
Yeah, and we'll also get to see how many times it goes into the if compared to everything else.
So we expect it to be about half, right? Because we're comparing it against the average. So we expect this number here that's running to be around 6,900. Now, because the average isn't really
not the median,
it won't be exactly half, but around 6,900 is what we expect.
All right.
Okay. So
yeah, it is a different. I mean, we got a bit of the detail back.
Okay. So let's set this to actually 1, and then see if we get even more detail here. So the idea now is here, if the pixel is dark, we do no contrast increase.
I see.
But if the pixel is bright, we contrast increase by a factor of 10.
And there we go.
Okay, so the dark areas are the exact same, and the white area, the white contrast is now been amplified.
Yeah, so we're getting. Let's make it easier on our eyes. Hide this one, and here we can see them sort of side by side, a bit more side by side. All right.
Yeah. So the brighter pixels are now enhanced. The darker ones are not touched.
Yeah. See, this whole part is identical, and then this whole top part is very much enhanced.
Yeah, and the roads are actually all white.
Yeah.
So you can. This is a simple idea, but just with this simple idea, you can actually come up with some very interesting filters that we can apply. One of the interesting filters that we can apply, maybe we should apply in this case, is to amplify only the red channel. So what we're going to do is we essentially only the red channel if it's bigger than the average red. So essentially, we're going to look at this set of colors, and only if it is actually the red is less than the average
Sorry.
red.
Sorry, hang on.
The average red.
Tab. Okay.
So if it's less, then we amplify by 1. If, of course, it's greater, we amplify by 10. But now we're amplifying all of these, which we don't really want. We just want to amplify only the red channel, so we leave the green and blue. So this will create an interesting effect. So if you had someone wearing, for example, lipstick, which we don't in this image, that lipstick would really be amplified. So
I see.
here, I don't know if you actually have any red shades, but we'll see some of the red colors being enhanced.
So this is basically enhancing all the red colors. So anything that is sort of reddish will become more red. Sounds pretty cool. And this is running much faster now that we're only changing one channel. Whoa, pretty red.
Yeah, so essentially, of course, 10 is a very strong number,
Yeah.
so it's really amplifying these red, but you can see that it's kind of creating a reddish filter applied to the image, but only to the parts that the red is above the
Yeah,
average
it's
red.
pretty interesting because you can still see the original parts, like these suspicious windows, maintained, but then anything that's a bit lighter is now basically red.
Right. So in the next course, we're going to be starting off here, and there's a few more things, of course, we'll talk about in this course, but the next course will focus on what changes you can do to the image, and then go from there about making a full app that has UI elements, that has controls. You can actually take a photo, and from there we'll put some basic filters in that you could actually modify an image.
Yeah, so I hope you had fun here with these images. I know I did. And you can play around with this math. Like this is basically doing some interesting math that you think might do an interesting effect. And you can play around with that and just see what effects you can create as well.
Now, one effect, maybe just before we go, of course, the app that we're building towards is the Shift app. So this has a filter, which we'll have some filter effects in Shift, but maybe what we could do is actually we could make the redness fade out depending on how far below the image you are. So essentially, we can make this modifier, which is 10, be dependent on the Y value of where you are in the image.
That is super cool.
Essentially, if you want let's say at the top for it to be, perhaps the top it should be 1,
okay.
and at the bottom it should be 10.
Sure. So we want to sort of interpolate from 1 to 10 depending on the Y, which is very interesting. So we can sort of start from 1 and then we add 9 times the basically percent we're at in height.
So here, once Y reaches the height, you'll have 1 plus 9, and when Y is 0, you'll have 1.
Yeah.
And what is that complaint that's giving?
It's just Xcode being dumb. Because if it's running, then there's no errors. You guys should probably have a better time than us with this because by the time this course is live, we'll be aiming. We'll make sure that Xcode 7 is available. And I guess it's not that obvious. I see it a bit. My math is. I think I know it's because. Is this still an integer? It's still integer, which it shouldn't be. At this point, we're going to have to cast one of these to a double. Okay. Because we're dealing with integers here, it's going to truncate. So it was just not doing what we wanted it to.
But I think it actually was casting the Y divided by the height, so that was always set to 0.
Yeah.
And so it wasn't really doing anything. So just, again, be careful about the type of variable you have. If you want things that are fading, essentially, they do need to be doubles. Integers sometimes will give you problems, although there are ways of using integers there as well. So now our modifier is a double. Of course, that creates a problem here, so we have to essentially typecast it around here.
Yes, so we'll have a double, but we can still cast that to an integer, and I think that will truncate. Okay. Maybe it won't. Maybe it will run. Maybe it won't. I'm going to guess it's not running for us. But yeah, so we should probably round this. So we can use the round functions. So let me type to round a double back to an integer. And for some reason, all these rounds return more doubles. But if we round this result and cast it to an integer. That should work out for us. And if Xcode is happy, which it doesn't seem to be, and it's not allowing us to add,
Yeah,
right,
so
it's not allowing us to add this integer. And yeah, so when doing simple math, Swift does get in the way a bit with types.
So
But now
what,
it's
what
gone.
you want to do essentially is if you're adding, dividing, subtracting, whatever you're doing, make sure you're aware of the types you have. It's usually a good idea to make sure they're all the same type.
Yeah, generally it won't be this annoying or difficult. It's mostly because our pixels are 8-bit integers, which is very important. That is causing this sort of messiness.
Right? But okay, and there we go. So at the top, it's all white, and as you get to the bottom, it becomes more red.
Yeah, I can see it, but I guess it's not too obvious. But yes, if you go down this building, it's getting more and more red as it goes.
Right. You could even, I was thinking if you lowered this number, so you made this like a 4, so it's not as intense. Let's see what that would look like. So now this is not as extreme in the contrast enhancement on the red channel.
And we're still only doing this for the redder pixels. Yeah. Right, it's finishing up as we speak. Oh, it's definitely more noticeable.
Yeah. Right, so I feel before, once you even got to maybe like a 6 or 7, you didn't have to go all the way to the 9. It was so much that it was just setting all the items to red. But now you can actually see it more. There's kind of a red hue that's this gradual shift down to this red contrast. So that by itself could actually be an interesting filter.
Yeah.
And you can use this idea to create many other types of filters, and we're going to do that. And again, later on, we're going to create a full app around this. That you can actually try different filters, shift different images together. So do a lot of cool things based on this.
Yeah. All right.
Cool. That's it.